So in the conductor, EMF is generating. That is the concept. Okay. Field is available. In the field, conductor is rotating. In the conductor, EMF is inducing. Whatever the amount of EMF inducing, that is converted into DC and which is collected by the brushes in the DC generator. But here, see, it is a alternator, AC generator. So here also same principle. But what is the difference? So here, field is constant, DC generator, please. Okay, field is constant, rotor is rotating. But in alternator, AC generator, field is rotating, conductor is constant. Okay, this is constant, rotating. Now what I am doing? Conductor I am keeping stationary, field is rotating. So I am changing their, I am interchanging their places. Field is converted to, field is stationary, that is converted to rotor. Whatever the conductors available in the rotor, that I have kept in a stator. That is the different. Okay, see here. So here this is stator frame which consisting of only conductors. Only conductors. So in rotor, rotor is having rotor conductors in DC generator. Here no rotor. Exactly there I am interchanging their places. Okay. In DC generator, where are the conductors? Rotor. Rotor having rotor slots. So in that rotor conductors are available. What I am doing here now? Instead of rotor, I am keeping these conductors in the stator. Stator is having stator slots. Stator slots. So why I have given this color coding? So this is three phase. Three phase. So one is called RYB. We can say three phase coding is RYB. R is nothing but red. Y is nothing but yellow. B is nothing but blue, or you can take black. RYB, red, yellow, blue, or red, yellow, black. This is the color coding. Okay, so wherever red is there, so red conductors. These conductors are connected like this. Conductors, only red conductors are connected, and we are keeping out. Y, yellow, like this. We are connecting like this and keeping outside. So output terminals are 3. Output terminals are how many? 3. Okay, generator. Generator means I have to rotate. So mechanical energy into electrical energy. Electrical energy means supply. So supply is we are getting in a 3-phase supply we are getting. That's why RYB. You can draw this one or you can draw otherwise that one. So when compared to that diagram, it is easy. So you can draw this one. Alternator construction means this one you have to draw. There is no commutator, there is no brushes. Okay, right. So conductor, where we are placing conductors? We are placing conductors in the stator. So conductors are stationary in alternator. Conductors are stationary. Okay, second one. Okay, only conductors having, that means armature. Armature means, that means stator consisting of stator winding which consisting of conductors. When compared to DC generator, AC generator means I am changing the places. Field. In the DC generator, where is the field? Field is at a stationary. North pole, south pole, north pole, south pole, and a pole shoe. Here field is in rotor. Where is the field? Field is in the rotor here. Field is in the rotor. Okay, so this is rotor. In this rotor I am using the field here. This is field. Field. Okay, same. Clockwise, north, south, anti-clockwise, south, clockwise, anti-clockwise. So here one terminal is given to this brush. This another terminal is given to this brush. So these two are called slip rings. Slip rings. Okay. So why we require slip rings? These slip rings will divide the voltage here. Okay. Plus minus. So for this, in order to become this north pole, south pole, two slip rings are required. Okay. So with respect to construction of alternator is concerned, okay, here field in DC generator, where is the field? Field is here. You see the diagram, okay, stationary, but here field is rotating here. Conductors are stationary. Okay, here also same principle. Whenever conductor rotating in a magnetic field, an EMF induced in the conductor in the DC generator. Here conductor is stationary, field is rotating. So in both cases what happens? Conductor cut by the flux cutting the conductor. The word is, okay, flux cutting the conductor cuts the flux. Both are equal, but the okay, conductor is starting here, flux after. So interchanging. Flux is cutting the conductor cutting the flux. That is the different. Only that is the different. So, okay, d pi by dt. In both cases, the flux is changing with respect to time. In both cases. Okay, so the principle is same. E is equal to d pi by dt. Whenever conductor is rotating in a magnetic field, okay, so this conductor cuts the magnetic field, so pi is changing, flux is changing with respect to time, E is equal to d pi by dt. So here the field, see, whenever it is a generator means you have to rotate, so field I am rotating by turbine, I am rotating the field. So whenever I am rotating the field, this north pole, south pole, what happens? Flux is delivered. Okay. Flux is delivered from the north pole, flux absorbed by the south pole. Flux is delivered by north pole, flux is absorbed by the south pole. So flux will, like this, flux will be delivered like this. So what happens? Conductors are available in the stationary. Okay. So this flux is cuts the d pi by dt. Flux is changing. This whatever the flux which is delivering here, that is cutting the conductor. So automatically in the conductor an EMF induced. Because of these conductors are three phase RYB. They are electrically apart by the, so 360 by 3, 120. So electrically apart. So an EMF, that is AC EMF is generating. So with respect to alternator is concerned, this is the diagram construction. Only different is I am interchanging this. Field, where is the field? Rotor. So rotor consisting of field. What is the use of field? What is the use of north pole, south pole, which will deliver the flux? In DC generator also, why we have to use the field which will deliver the flux? There stationary, here rotating. Okay. And whereas the conductors in the DC generated, conductors are in the rotor, conductors are rotating. Whenever these conductors are rotating, these conductors cut the magnetic field. Here, whenever field is rotating, this field is cuts the conductor. Field is cut by the conductor here. So an EMF induced in these conductors. So RYB, red, yellow, blue. So three phases electrically, okay, it is separated by 120 degrees electrically. So that is three phase. Output is three phase will get. Okay, so depending upon the construction of the rotor, okay, we are having two type of rotors, two type of fields. I can get the two type of rotors. So this is one type, other one is this type. Field is there now? Field is two types. See, here also same. Okay, like this I am rotating. North pole, south pole, north pole, south pole. So you can use any one. Same, this one stationary is okay. Stator is having stator conductors, which is known as conductors, which are apart by the three phase, 120 degrees apart. 3 phase. Okay, 360 by 3, 120. So 120 degrees apart. Same when compared to this diagram stationary is same, but we are having two different rotors. Okay, so this is one thing, one rotor, this is other rotor. Okay. So here also, which is required to draw when the question comes from the construction of the alternator. Which one is easy? That is up to you. Which one you will draw? That is up to you. Okay. If you having time, you draw. Okay. Otherwise, this one. Which is easy? That is up to you. You can draw. Okay. So here also you are having slip rings. Here also you are having slip rings. There is no change, only this one outermost is there, na? Outermost. This is different. Okay. One is called cylindrical rotor, other one is called squirrel cage rotor, wound rotor. Okay. So see, this is salient pole. We can call it as salient pole. This is called cylindrical. Cylindrical, why? Because it is in circular in nature. It is like cylindrical in a circle. So cylindrical type rotor. Here salient pole. Salient pole means only poles will be, okay, outermost, and this space is less. There is no anything is there. Here both are looking like same. Okay, so these are the two different type. Okay. Okay. So when with respect to alternator is concerned, with respect to construction is concerned, what is the different? Just field is here shifted from stator to rotor. This is field here. Okay, here also same, field is rotor. Here also same, slip ring and brushes. Here also slip rings and brushes. Okay, so these are called slip rings. Okay. You can draw anyone, anything, not both, anything. Whichever easy, you kindly learn that one, draw. Okay. So in alternator, what are the two different parts? Here also two different parts. One is called stator, other one is called rotor. So here stator consisting of conductors, not field, conductors. So conductors are 120 degrees apart. That is called three-phase winding. Why? Because it is a AC generator. So AC it is, not DC. DC is not required. So commutator is not required. And that whatever the amount of which are converting AC to DC, that is collected by the brushes. So brushes are not required. Okay, right. So here conductors. First thing, conductor. Stator consisting of stator conductors, which are known as stator winding, which are three-phase. That's all. Nothing is there. No pole shoe. There stator conductors are there, field, pole shoe. Here not required, only one thing. Second one is rotor. When compared to DC generator, it is very, very easy, but the diagram is okay. Rotor consisting of poles, that is field winding poles, north pole, south pole, north pole, south pole. Here pole shoe not like that. Okay, so directly pole is nothing but it's one like this. It is made up of, it is iron. Okay, we are wounding this iron, cast iron piece, copper wire, clockwise, anti-clockwise. Directly it is, see, it is circular. There is equal distance. Separate pole shoe is not required. Direct to pole is act as a, okay, will distribute the equally flux to the stator. There is no additional pole shoe is required. Okay, so here field I am rotating. Okay, so this here we require slip rings here. Slip ring means here we have to apply DC to the poles. That's why we require slip rings. These are available in cylindrical and this one also. Okay, so this is about alternator construction. The principle is same. DC generator principle is equal to AC generator principle. There is no different. Only the difference is the location of field and the location of conductors are interchanging. In DC generator, conductors are placed in the rotor slots. In AC generator, conductors are placed in the stator slots. But they are three phase, 120 degrees electrically apart. Okay, right. And now rotor is having here, field winding, field north pole, south pole, north pole, south pole, and slip rings and brushes. Okay, why we require brushes? By using slip rings. Okay, this by using these slip rings we are we are converting this one north pole south pole magnets, okay, not permanent, we are making them, okay, magnets by using the slip rings. Okay, so we are rotating this, rotor is rotating, that is field is rotating, flux is delivering, flux is absorbing. Whatever the flux, while rotating this rotor, whatever the flux which are delivered is cutting the conductor. So in this conductor EMF is inducing. So directly AC is inducing. So there is no need of converting AC to DC. So directly we are taking AC output. Okay. So we are having two type of rotors. One is called salient pole, other one is called cylindrical. Cylindrical pole is look like circular. This is salient pole, means directly we are coming, this north pole south pole is coming out of the cylinder rotor. Okay, this is about construction of the alternator. Okay, there is no EMF equation is not required for this, only construction of alternator, working of alternator. Working is same with respect to DC generator. Their conductor is rotating. Okay, DC generator working, how will be the working of DC generator? Field is available. I am rotating the conductor. Whenever a conductor is rotating in a magnetic field, an EMF induced in the conductor. That is DC generator working or principle. Here conductors are stationary. All conductors are available stationary. So whenever field is rotating, okay, whenever field is rotating, the flux is cutting the conductors, and EMF induced in the conductor. So directly whatever the amount of EMF is induced is, that is AC. So that AC directly we are taking out. This is about alternator construction. If you know DC generator, exactly opposite to that. Why? Because their location is changing. Field here rotor, their stator here rotor. Rotor conductors, armature winding there in a rotor. Here rotor conductors are in stator. Okay, field is available in rotor, conductors are available in stator. Both are interchange. So if you know the DC generator, exactly oppositely you write down. Their commutator is there, delete that commutator. Here slip rings are there. Slip rings. Okay, right. This is about alternator. Okay. So if you want to draw this diagram, you draw. No sir, we don't have time, means kindly learn how can you draw this alternator construction. Okay. He may ask, okay, explain about construction of alternator. Explain about the principle of operation of working of alternator. Principle and working means no need of drawing the diagram. Construction means if you ask about construction only, you draw the diagram. Okay, either of one you can draw. Okay, do you understand now? What is the difference between DC generator and AC generator? Only field and rotor, the location is changing. Conductors are in rotor. Here conductors are in stator. Field is stator there. Here in the rotor. Okay. You keep one after another. Okay. Diagram. Morning you are done, na? You compare that diagram to this diagram. Easily you can understand where is the stator, where is the rotor, where are the conductors, where are the field. Okay. Commutator is not required here. Why? Because we are no need to convert DC to AC. Okay. Right. Already I shared the notes actually. So kindly understand what are the meaning here. Okay. So this is three-phase conductors. Three-phase conductors. They are electrically apart by 120 degrees. Okay. Why? Because total 360 degrees. 360 by 3 phase. 3. How much? 120. So 120 degrees apart electrically. Okay. Next we will move to the transformer. Okay. If you know transformer, then induction motor is easy. Why? Because induction motor is nothing but rotating transformer. Induction motor is nothing but rotating transformer. The motor which is rotating, the transformer which is rotating is nothing but induction motor. Okay? Yes. If you are able to draw, you can draw. Otherwise, we will move to the transformer topic. Can I move to the next topic? Are you drawing? Draw. In 5 minutes you have to draw. Otherwise you try to draw. If 100% it will not come, but what are the different parts you are having? No, only one is enough. This one is enough. Salient pole alternator. Here also two parts. What are they? Stator and rotor. Stator consisting of only conductors, that is three-phase conductors. 120 degrees apart. You have to use that word. 120 degrees apart. Three-phase AC conductors are placed in the stator of the alternator. You can use sketch, no need to worry in the exam. Why you have to use the sketch? Different colors. In order to differentiate red, yellow, blue, you can use the sketch. So construction means diagram is very, very important. Only exam lo diagram చూస్తారమ్మా. diagram లో మీరు రిప్రజెంట్ చేసిన పార్ట్స్ మాత్రమే చూస్తారు. కింద రాసే నువ్వు నీ ఇంగ్లీష్ చూడరు. If diagram is okay, good, every part is mentioning, then they will give the marks. Okay? Right. ఏమైందమ్మా, డ్రా చేయడానికి రావట్లేదా? సర్కిల్ బదులు రెక్టాంగులర్ అయిందా? సో యూ హ్యావ్ టు యూజ్ దట్ కంపాస్ ఆర్ ఏమంటావు దాన్ని, ప్రొటెక్టర్ ఏమంటావు అది. తొందరగా డ్రా చేయండి అమ్మా. కైండ్లీ లర్న్. దెన్ విల్ మూవ్ టు ది ట్రాన్స్ఫార్మర్. ఇట్స్ వెరీ వెరీ ఇంపార్టెంట్. Only with respect to alternator is concerned, explain the principle and working of alternator. That is one question. Other one is explain the construction of alternator. You have to draw the diagram and you have to explain about each part. Okay? What is the function of slip rings here? What is the function of slip rings here? What is the function of slip rings here in alternator? అందరు ఏదో ఆన్సర్ అనగానే ఏదో చెప్తున్నారు. ఎనీబడి అబ్బాయిలలో ఎవరు చెప్పు. ఏ బాబు నువ్వు చదువుతావు కదా, చెప్పు. సెకండ్ వన్ నువ్వు కాదు, నీ వెనకాల. వాట్ ఇస్ ద ఫంక్షన్ ఆఫ్ స్లిప్ రింగ్స్? ఎట్ slip rings 3 phase here. In stationary only you are having 3 phase. Okay, here we are having field, flux is delivering. Here we are generating the EMF in the stator. We are getting output as the AC. In stator only you are having AC. Okay, what about this one? Slip rings for, okay, to get the DC supply. DC సప్లై కావాలి కదమ్మా. 2 బ్రషెస్ కావాలి కదా, ప్లస్ మైనస్ వీటికి ఉంటుంది. ఓకే, సో విచ్ విల్ గివ్ ది DC సప్లై టు ది రోటర్ పోల్స్. ఓకే, దట్ ఈస్ ద మీనింగ్. సో దట్స్ వై వీఆర్ హ్యావింగ్ 2. One is positive brush, other one is negative brush. Positive brush, negative brush, which will give DC supply to the poles of the stator, a rotor, not stator, rotor. ఫీల్డ్ ఉంది చూసినరా, ఫీల్డ్ అనేది కంపల్సరీ ఓన్లీ DC సప్లై చేస్తేనే నార్త్ పోల్ సౌత్ పోల్ అవుతుందమ్మా. అర్థమైందా? Where is that my pen? Where is the stylus? Stylus is given. Here it is. Okay, so I am making this one north pole south pole. Okay, so whenever I am giving DC supply here, DC supply, this is acted as north pole, it is acted as south pole. AC ఇవ్వద్దు, ఈ వైండింగ్కి AC ఇవ్వద్దు. AC ఇస్తే ఏమవుతుంది? దిస్ ఇస్ నార్త్ పోల్ సౌత్ పోల్, నార్త్ పోల్ సౌత్ పోల్, నార్త్ పోల్ సౌత్ పోల్. అది రెండు చేంజ్ అయిపోతుంటాయి, ఇంటర్చేంజ్ అట్లొద్దు. ఓన్లీ ఐ రిక్వైర్డ్ నార్త్ పోల్ పర్మనెంట్, సౌత్ పోల్ పర్మనెంట్, క్లాక్ వైజ్ డైరెక్షన్ వౌండ్ చేయాలి, DC సప్లై ఇవ్వాలి. DC, సో దట్స్ DC సప్లై ఈజ్ గివెన్ టు ఫ్రమ్, ఇట్ ఈస్ టేకెన్ ఫ్రమ్ ది స్లిప్ రింగ్స్. అవి ఎక్కడ ఉంటాయి? బయట ఉంటాయి, ఇట్లా బయట. అక్కడ బ్రషెస్ ఉంటాయి, ఓన్లీ అక్కడ ఇస్తారు. ఓకే, ఒక స్మాల్ బ్యాటరీ కనెక్ట్ చేస్తారు బయట. మీరు ఆ DC జనరేటర్ చూస్తే అర్థమవుతుంది. బయట ఒక బ్యాటరీ కనెక్ట్ చేస్తారు. ఆ బ్యాటరీ ప్లస్ టెర్మినల్ మైనస్ టెర్మినల్ తీసుకెళ్ళి ఇక్కడ ఇస్తారు, స్లిప్ రింగ్స్ ఇస్తారు. సో ఫ్రమ్ ది స్లిప్ రింగ్స్ బ్రషెస్ విల్ సి. ఇక్కడ చూడండి, ఈ కనెక్షన్ ఎక్కడ ఉంది? ఇలా అని ఇలా వెళ్ళిపోతుంది, పాజిటివ్ వెళ్ళిపోయి మళ్ళీ ఇక్కడికి వెళ్ళిపోతుంది, బ్రషెస్ దగ్గరికి వెళ్ళిపోతుంది, స్లిప్ రింగ్స్కి వెళ్ళిపోతుంది. అది ఆ స్లిప్ రింగ్ ఉంది కదా, ఇలా ఉంటుంది స్లిప్ రింగ్ అని. ఇక్కడే రెండు ఉంటాయి, ఇక్కడ ఒకటి ఇక్కడ ఒకటి. దీనిపైన ఒక ఇలా డీసీ ఇవ్వాలి. ఇక్కడ డీసీ ఫీల్డ్ ఆల్వేస్ డీసీ. బ్యాటరీ నుంచి ఇస్తారు, స్లిప్ రింగ్స్కి ఇస్తారు. స్లిప్ రింగ్ నుంచి బ్రషెస్ నుంచి దీనికి వెళ్ళిపోతుంది అంతే డీసీ. ఓకే, డీసీ ఇవ్వకుండా ఏసీ ఇస్తే ఏమవుతుంది? ఫర్ ఎగ్జాంపుల్ ఇఫ్ ఐ గివ్ ది ఏసీ టు దిస్ వైండింగ్, వాట్ హ్యాపెన్స్? ఏసీ అంటే ఆల్టర్నేటింగ్ కదా, పాజిటివ్ మ్యాగ్నిట్యూడ్ నెగిటివ్ మ్యాగ్నిట్యూడ్. దిస్ విల్ యాక్ట్ యాజ్ ఎ నార్త్ పోల్ కొంచెం సేపు, మళ్ళీ సౌత్ పోల్, నార్త్ పోల్ సౌత్ పోల్. అట్లా కావద్దు. ఇట్ షుడ్ బి పర్మనెంట్ నార్త్ పోల్, ఇట్ షుడ్ బి పర్మనెంట్ సౌత్ పోల్. ఇట్ షుడ్ బి పర్మనెంట్ నార్త్ పోల్, ఇట్ షుడ్ బి పర్మనెంట్ సౌత్ పోల్. కాబట్టి డీసీ సప్లై ఇవ్వాలి. ఇప్పుడు ఇది ఉంది కదా కాపర్ కలర్, ఆరెంజ్ కలర్. ఈ ఆరెంజ్ కలర్ అనేది డీసీ సప్లై. వీ విల్ గివ్ డీసీ సప్లై టు దిస్ ఆరెంజ్ కలర్. See, one terminal is here, other terminal is here to the slip rings. ఏంటమ్మా డ్రా చేస్తున్నావా, నవ్వుతున్నావా? ఏం డ్రా చేస్తున్నావు? మేడం ఇప్పుడు చెక్ చేస్తుంది. When will your mid examination? November 25th. November 25th. 4th. 25th అనుకుంటామ్మా, 24th కాదు. 25th. మరి మమ్మల్ని 24th రమ్మన్నారు కదా. మేబీ ఫ్రమ్ 25th ఆన్వర్డ్స్ ఐ థింక్. ఓకే, అయిపోయిందా? వాట్ ఇస్ ద ప్రిన్సిపల్? వాట్ ఇస్ ద నేమ్ ఆఫ్ ది ప్రిన్సిపల్? Faraday's laws of electromagnetic induction. DC generator gaani, AC generator gaani. The name of the principle is Faraday's laws of electromagnetic induction. DC generator works with Faraday's laws of electromagnetic induction. AC generator, that is alternator, works with Faraday's laws of electromagnetic induction. Okay. So it is a transformer. Okay. Next topic is transformer. So when compared to DC generator, when compared to DC motor, alternator or induction motor, transformer is very easy. Okay, it has one core, that is it has one cast iron piece and one winding. Only two parts. How many parts we are having? Only two parts. One is core, that is cast iron. Okay, so this is called cast iron, this one. Okay, this is cast iron, and we are winding around this cast iron. Okay, so this is called limb. This state portion is called limb, L-I-M-B, limb. On the limb we will wound the winding. So I said morning, what is the function of transformer in application wise? What is the application wise? Input 230, output you require 9, okay 9. You require 1000, okay you require 1000. You require 1000, okay. You require 200, okay. For example, input 11,000, input is 11,000, output is 200, 300, 9, 10. So whatever the available amount of voltage is available at input, that can be vary input and decrease. Okay, you can increase the voltage, you can decrease the voltage. If okay, V1 is more, V2 is less, what happens? Voltage is leveling down, step down transformer. If V1 is less, V2 is more, so input is, for example, only 100 voltage, output is more than 100, V2 is more. Stepping up, step down transformer. So in the charger we are having, mobile charger we are having step down transformer. What it will do? It will decrease the level of voltage. Input voltage is more, secondary voltage, output voltage is less. Okay, that is the main function. Okay, so with respect to construction is concerned, only two. How many parts we are having for the transformer? Only two parts. One is called iron core, cast iron core. On this iron core we will wound the winding. Okay, how many winding we are able to wound? You can wound any number of windings, but here only you are having two windings. Okay, two windings. This is one winding wounded here, single phase, and here one winding output. There is no connection between this winding, okay, input winding and output winding. Okay, input winding and output winding. So this winding, okay, this left side winding is called input winding. Okay, or you can say primary winding. Why we have to say it is a primary? Why not secondary? So it is connected to supply. Supply means we will insert our mobile charger in the socket. That is, we are giving supply. So supply means input. The winding which is connected to the supply is known as primary winding, input winding. Output winding, this one is called output winding. This one, output winding. Or you can say secondary winding. So now, which is connected to the secondary winding? Why we are calling it as a secondary winding? The winding which is connected to the load. Load means any electrical appliance. Example, mobile phone. For the charger output, two terminals are there. Charger output. We will keep the charger in the socket of our mobile phone. Okay, which is output is two terminals. So here mobile phone. Example is mobile phone. So the winding which is connected to the load is known as, okay, secondary winding or output winding. So how this voltage level is changing? How the voltage level is changing? Input is 230, output is 9. How this 9 volts, how it is reducing now? How it is reducing? On what parameter is depending? 230 voltage, 9 volts are decreasing. How it is reducing? On what parameter? So it depends upon the simple, it depends on number of turns. Number of turns. So here voltage is less, 9 volts is example. You can say it is a 230. Example I am saying. It is a 9 volts. How it is reducing? Simply it depending upon only one parameter. How it is reducing? How I am getting less voltage? Okay. So example say in order to get 230 voltage, here N1 is, for example, N1 is 100. Maybe, not exactly, maybe. Let us assume. In order to get 230 voltage, here number of turns are 100. So in order to get 9 voltage, simply by seeing you can say 200 turns, 230 voltage. 9 voltage, how many turns? Maybe the turns are very less. N2 turns are there, na? These turns are very less. Maybe 10 or even less than 10. So number of turns, how many turns I am wounding? Turns are there, na? Less turns. So here N1 is more than N2. Example, V1 is more than V2. 239. So more turns, less turns. So if you wound the less turns, we will get less voltage. If you wound more turns, we will get more voltage. So the voltage level, the value of voltage is entirely depending upon the number of turns. How many turns I am wounding? Depending upon number of turns, the value is changing. Voltage level changes. In order to get more voltage, what I have to do? Than the 230. So here 100 turns. So more than 100 turns if you wound here, you will get more number of turns, more number of voltage than the 230. Okay. So voltage less means turns are less. Voltage more means turns are more. So the direct relation. More voltage, more turns. Less voltage, less turns. Okay. With respect to turns only. So it means whenever I require 9 volt, only 2 turns or 3 turns enough to get the copper wire is there, na? 2 turns are enough. I will get 9 voltage. Okay. So number of turns, depending upon the number of turns, this output voltage decrease. Okay. So this is about construction. With respect to construction, only 2. This one is called iron core. What is the function of iron core? You have to tell me now. What is the function of this iron core? This is iron core, iron piece. Not a single piece, it is a, okay, individual pieces I am stacking. Individual pieces like biscuit. Okay, 10 biscuits make one packet, na? So 1, 2, 3, 4 bunches. Small strips, okay, bunches which forms the core. Okay, like this. This is 1. Okay, other one. Like this 1, 2, 3, 4 which will form the very big core. Okay. So for that core I am wounding this. Like this clockwise. So input supply. So input supply. So I am naming suffix as 1. V1 input. What is the current flowing here? I1. I1 current is flowing. So input current suffix is 1. V1 I1. Okay. Output voltage V2. Suffix secondary. Second means 2. Current is 2. I2. Load means any load. Any electrical equipment. Any electrical equipment. Mobile charger, any motor, anything. Okay. So here I2, V2. Okay. Winding is there. Primary winding, secondary winding. So what is the function of this core? Core is made up of cast iron. Core is made up of cast iron. Okay. Core is made up of cast iron. Okay. The function of this core is, okay, this core will carries the flux. Carries the flux. So in this core, what will have magnetic field is available in the core. Magnetic field is available in the core. Okay. So this magnetic field, that is nothing but flux, will rotates clockwise direction. Rotates clockwise direction in the core like this. We cannot see this one. We cannot see. Okay. It will rotate like this. So whenever you are moving towards the or nearer to the transformer, you are getting one sound. You hear about that one? That sound is nothing but that indicates that flux is revolving in the core. Flux is revolving in the core. That's why you are getting that noise. That noise is nothing but flux flowing in the core. Okay. So what is the function of core? What it will do? It carries the flux. Okay. Is there any connection between primary winding and secondary winding? Is there any connection between primary windings? No. Okay. Then what is the common between primary winding and secondary winding? Flux is common. Same flux is flowing here. Same flux is flowing here. Okay. Primary winding, how much flux is there? Pi m. Secondary winding, how much flux is there? Pi m. Same flux is flowing. So common is flux. Okay. Voltage, no. V1 is different, V2 is different, I1 is different, I2 is different, but pi m is same. Here the pi m. Here the pi m. Flux is common when compared to both windings. Currents are not common. I1 is not equal to I2. V1 is not equal to V2. Okay. Right. So that is the function of core. Winding. What is the function of winding? What it will do? What it will do? In the here winding, we are having winding. Why we require this winding? In the winding only EMF will induce. EMF will induce. In the winding, EMF will induce. Primary induced EMF, secondary induced EMF. E2 is there, na? This is called as E2 is nothing but EMF. E1, primary induced EMF, secondary induced EMF. E1 and E2, primary induced EMF, secondary induced EMF. Okay. So in order to induce an EMF in the winding, in order to induce an EMF in the winding, okay, we require this winding copper wire. So winding only which will induce, in this winding only EMF will induce. Okay, flux will be established. This flux will be flows to the core. Flux is flows to the core and EMF is inducing. I will explain working. Okay, before that just construction. Okay, V1, I1, E1, N1, N2, E2, V2, I2. Okay, core and winding. This is about construction of the transformer. Okay, construction of the transformer. So with respect to working of transformer, okay, so how it will works? What is the principle? Principle is Faraday's laws of mutual induction. Transformer works with the principle of Faraday's law of mutual induction. Faraday's laws of mutual induction. What is the meaning of mutual induction? See, there is no connection here. There is no connection. But how we are getting voltage here? There is no connection here. How we are getting current here? How I am getting current? How the current is flowing in the secondary winding? It is output only. Winding, see, it is only output here. like this winding is there na, output. How I am getting current here? There is no connection between here primary and secondary. How? So that is nothing but because of the flux which is established by the primary winding. Because of the flux which is established by the primary winding, we are inducing an EMF here. So mutually, not direct. Not direct, so mutually. So that's why we are calling as principle of Faraday's laws of mutual induction. Faraday's laws of mutual induction. Okay. So I will explain now. What is meant by that? How it works transformer? Okay, that you know what is that? The number of voltage level is changing because of the number of turns. Okay, that you know. But how the voltage is getting in the secondary winding, how it is inducing in the secondary winding, let's see here. Okay, right. So here it is a transformer, is a AC device, it is a static device. There is no rotating part. Is there any rotating part? Is there? No rotating part, only stationary. It will not. So transformer doesn't have any rotating parts. Okay. So here see. So here it is a core. I wounded a copper wire around this limb or cast iron. Okay. So this is the AC voltage. AC voltage. So whenever AC supply, AC is given to the primary winding, whenever AC supply is given to the primary winding of the transformer, what happens? So this winding is wounded around the core, okay, and closed circuit. It is a closed circuit. It is starting here, closed circuit, okay, closed circuit. So what happens? What happens? So because of the closed circuit, a current of I1 will flow. Yes. So current will flow from here. It is AC supply. Okay, like this AC supply. Current will flow from here like this and ends at here. So because of closedness, a current of I1 is flowing. So whatever the amount of AC we are applying, AC voltage, the current also AC current only. The current is also in alternating in nature. That means AC voltage. That means AC current. AC voltage, AC current. I am applying a AC voltage. So because of the circuit is the closed one, so we are getting AC current, which is flowing in the primary winding of the transformer. Okay. So this winding, how this winding? This winding is wounded around the iron core. So because of only one reason, because of this winding is wounded around the core, this winding is capable of establish a flux in the core. Okay, a flux will be established here. How it will flow? It will flow like this, clockwise, and then it will return here like this. A flux of pi m is establishing here. Why it is establishing? That is the principle. Okay, so a flux is establishing. Okay, so voltage is AC, current is AC, flux also AC. The flux which is established in the core also AC. So this is nothing but d pi by dt, you can say, changing with respect to time. Okay, so because of a flux is established in the core, this flux is capable of establish a EMF. So a primary induced EMF will set up in this winding. Primary induced EMF, that is E1, will set up in this winding. So whenever there is a d pi by dt is available, this is capable of establishing an EMF, that is E. whenever the d pi by dt is equal to E, in the generator also E is equal to d pi by dt. Here also d pi by dt E, that is the main principle, Faraday main law. Whenever flux is changing with respect to time, so this changing with respect to time is having capable of inducing an EMF. In the generator also, flux cut by the conductor and EMF inducing the conductor. Here also same, but here there is no moving part, but because of the woundness, flux is established. This flux is changing with respect to time, is having capable of induce an EMF. Okay, that is called E1. So this E1. Okay, right. Now what happened? This flux is flowing through the core. Yes, revolving in clockwise direction like this. It is flowing through the core in clockwise direction 24 hours. Whenever supply is there, okay, it is revolving. So this flux is now, flux is flowing here. Winding is there. There is no voltage here. There is no voltage, only winding is available, and in the core flux is flowing. Yes, that is alternating in nature, d pi by dt. How it is d pi by dt. Here also, because of the flux is flowing through the core, winding is around available, flux is flowing, winding is available around the core. So this d pi by dt also here is capable of establish a voltage, that is called secondary induced EMF. Secondary induced EMF, that is called E2. Okay, so same, that voltage in parallel, voltage is same in parallel, so E2 is nothing but V2. Here also E1, there voltage V1. V1 is equal to more or less is equal to E1. There is no losses actually. So minorly it is changing. Okay. So V2, E2, V2 also more or less equal to V2. Now how I am getting V2? Only because of flux. How the flux is established here? Because of the primary winding. Because of the primary winding. Okay. So the EMF induced in the secondary winding. The EMF induced in the secondary winding is because of the flux. Okay, which is established because of the primary winding. Yes, ఇందులో EMF ఎట్లా వచ్చిందమ్మా, వోల్టేజ్ ఎట్లా జనరేట్ అయింది, ఫ్లక్స్ వల్ల కదా. ఆ ఫ్లక్స్ ఎలా వచ్చింది, ప్రైమరీ వైండింగ్ వల్ల కదా, డైరెక్ట్ కాదు, ప్రైమరీ వైండింగ్ వల్ల కదా. అంటే డైరెక్ట్ కాదు, డైరెక్ట్ కాకుండా ఇంకోటి ఆపోజిట్ ఏంటి, డైరెక్ట్ కాకుండా మ్యూచువల్. సో దట్స్ వై ద EMF induced in the transformer is mutual in nature. That's why the law name is Faraday's laws of mutual induction. The EMF induced in the transformer is only mutual induction, not direction, not direct. Okay, so E2. Now number of turns are there. How many number of turns are there? N2 are there. How many number of turns? N1 is there. So how much EMF is inducing? How much EMF is inducing? That is depending upon the number of turns. If it is 1 turn, small EMF will induce. More turns, more number of turns induce. Okay, so you can write this one as E is equal to N d pi by dt. So number of turns, the EMF induced is equal to N d pi by dt. Generally you can write. So number of turns will decide the induced EMF magnitude. Okay, magnitude of number of, okay, magnitude of EMF, whether it is a primary, whether it is a primary, whether it is a secondary, it is purely depends upon the number of turns, that is N1 or N2. Okay, N1 or N2. Okay, right. This is about working and principle and construction. Okay, is there any doubt is there here? Is there any doubt? Construction is very easy when compared to DC generator and alternator. Easy? Okay. Working? How it works? By the principle of Faraday's laws of mutual induction. How can you explain that working? Simply, whenever two windings are there, you draw this one. Okay. whenever AC supply is connected to the primary winding. Okay, so because of the closedness, a current of I1 is flowing. So applied voltage is alternating. Current flowing is also alternating. This voltage and current, because of the woundness of the winding around the core, this in the core, in the winding, a flux will be established. Flux will be established. So this flux is how this flux also alternating in nature. This flux is also alternating in nature. Okay, so d pi by dt. So the flux which is established in the primary winding in alternating in nature is capable of establish an EMF which is known as E1. Okay, which is known as E1. Primary induced EMF. The flux which is established in the primary winding, the flux which is flowing in the core also links with the secondary winding. So the flux is changing with respect to time is here also, which is capable of establish an EMF. That is called E2. E is equal to d pi by dt. So the magnitude of E1 and E2 is depending upon the number of turns in the primary, number of turns in the second. This is about working. Okay, so the EMF which is induced in the secondary winding is purely because of the primary established flux. That's why the EMF is called mutually induced EMF. This how we are generating this one, mutually induced EMF. Because of the primary flux, not direct by own, it is not getting. We are taking from the primary winding. From the primary winding, we are getting flux. That flux is here. Okay, you understand? This is about working. Okay, principal working construction. And you are having EMF equation. Okay, this is the formula actually, but you have to get the equation. What is mean by d pi? What is mean by dt? You have to write down. Okay, EMF equation of the transformer. Okay. Next we will move to the EMF equation of the transformer. Okay. Okay, right. Now EMF equation of the transformer. EMF. So EMF equation of the transformer. So DC generator, EMF is inducing. So that is, what is the formula? Generator formula, EMF equation, pi z np by 60A for the generator. DC generator. AC generator we doesn't require. AC generator, that is alternator, EMF equation not required. Okay, right. Why? Because which is not there in the cell bus. Not required means not there in the cell bus. Whatever the cell bus is, okay, depending upon the cell bus only I am explaining. Okay, right. Now EMF equation of the transformer. So how can we get this one? How can, okay, what is the formula general? So what is the formula? Formula, that means principle, Faraday's laws of electromagnetic induction. Okay, that is nothing but Faraday's laws of mutual induction. Okay, mutual induction with the principle of mutual induction. What is the formula generally? E1 is equal to N1 d pi by dt, or you can write E2 is equal to N2 d pi by dt. So here 1 indicates primary, 1 indicates primary, 2 indicates secondary, 2 indicates secondary. So this is how we got this one, by principle. By the principle we got. Okay, but what is d pi, what is dt, you have to get. If you are able to write down d pi and d pi, then equation is over. Okay, what is d pi, what is dt, I will tell now. Okay, omega t, this is pi. So alternating in nature. How the flux? Flux is alternating in nature. So plus value, minus value. Okay, what is the y value? Flux. So the magnitude of flux is increasing and getting maximum. Where we are getting? Here we are getting maximum. Here negative maximum. Okay, minus pi m. Okay, from here, what is the time period? T. Total time period. Okay, how can you define time period? Huh? How can you define time period? What is the definition of time period? Time period. Define time period. Huh? Huh? Time? Time? ఏమంటా? నిలబడి చెప్పు, చెప్పవా? One set of positive and negative values. Okay, time taken to complete one set of positive and negative values is known as time period. Time taken to complete one set of positive and negative values. Only one set, not repetition. In nothing but, okay, the total time is nothing but time period. So what is the time period here? That the time period of this waveform is capital T. So half means T by 2. Okay, at what time we are getting maximum value? At what time? Capital T by 4 we are getting maximum value. Yes, we are getting maximum value at T by 4. Okay, so here d pi is nothing but pi m. We are getting the value of maximum value, 0 to maximum value, pi, 0 to pi m. What is dt? When we are getting pi m I am getting in a t by 4. We are getting pi m with respect to t by 4 time. So in t by 4 time we are getting pi m. Yes? What is the time here? I am getting this maximum value at what time? T by 4 time. 0 to t by 4 time I am getting maximum value. I have to take maximum value, not minimum value, not 0 value. Okay. So I am getting maximum value d pi with respect to t by 4. In what time we are getting maximum value? T by 4 time. Substitute this one in the formula. Okay, you can consider any one. So E1 is equal to N1 pi m by t by 4. Okay, that is nothing but N1 4 pi m by t. Okay, can I write 1 by t is equal to frequency? Can I write inverse of time period is equal to frequency? Do you know the okay, inverse of time period is nothing but frequency. Frequency is nothing but number of cycles per second. Frequency is nothing but number of cycles per second. Okay, so now it is written as now N1 4 pi m f. So what is this? This is called average induced EMF. Average induced EMF is equal to N1 pi m f N1. E1 is equal to, this is average induced EMF. Okay, so this 230 volts is there na, single phase 230 voltage, single phase 230 voltage. Which voltage that one? Which voltage? Single phase 230 voltage is there na, 230 voltage I am saying single phase. Which voltage that one? In AC how many ways of defining parameter of the voltage? Average value, maximum value, instantaneous value, like this we are having na. Which voltage that 230? Which voltage? RMS value. Is there any relation between RMS value to average value? Is there any relation between average value to RMS value? VRMS? Relation between RMS to average. What is meant by form factor? What is the formula for form factor? You are unable to remember this formula means కష్టమమ్మ ఇట్లయితే చాలా కష్టం. నువ్వు ఆ షార్ట్ ఆన్సర్ ఏవి రాయలేవు. ఎగ్జామ్ ముందు రోజు చదువుతావా? ఎన్ని 6 యూనిట్స్ వస్తుందా? వాట్ ఈస్ ఫార్మ్ ఫ్యాక్టర్? డిఫైన్ ఫార్మ్ ఫ్యాక్టర్. ఇట్స్ a ratio of VRMS to V average. What is the value of form factor of sine wave? What is the value of alternating quantity of form factor? Derive చేసినాం కదమ్మా, అది మనము derive చేసినాం కదా. Form factor of alternating quantity is 1.11. The formula is VRMS by V average. కాదా? VRMS by V average, VRMS by V average by VRMS. VRMS by V average is equal to 1.11. Okay. So here average induced, this is called average. Okay, average induced EMF is equal to how much? 4f pi m n1. If it is E1, it is n1. Okay, now we require RMS. Okay, ERMS 1 is equal to, what is the formula? Form factor into E average, E1 average. Okay, for with respect to form factor of the alternating quantity, form factor. Okay, form factor, FF and 10 form factor is how much? 1.11. So multiply here E1 RMS. By default you can say it is 1.11 into 4 into f into pi m into n1. That is nothing but 4.44 f pi m n1. So this is the EMF equation of the, why? Because transformer input is AC, output is AC. So we require AC voltage. AC, so alternating means always we represent in a RMS. Okay, alternating, this AC voltage always will consider only RMS value, not average value, maximum value, instantaneous value. That's why whatever the amount, whatever the equation we got, that is average induced EMF, that has to be converted into RMS. So what is the EMF equation of the transformer? 4.44 f pi m n1. If it is E1, n1. If it is E2, n2. Okay, simply you can write this one as V1 is equal to 4.44 F pi m N1. V2 is equal to 4.44 F pi m N2. So I said, so directly see, when compared to both equations, 4.44, 4.44 common, frequency is common, pi m is common. What is the difference? N1 and N2. So V1 is directly proportional to N1, V2 is directly proportional to N2. If I get less voltage, I need to use the less number of turns. If I get more voltage, I have to increase the number of turns. So number of turns is directly proportional to the EMF voltage, induced voltage or available voltage. Okay. Okay. So after this, we can call it as one transformation ratio. One term is called transformation ratio. What do you mean by transformation ratio? Which is denoted as K. So you can write any number of statements. So it is the ratio of transformation ratio is nothing but is the ratio of secondary voltage to the primary voltage. Okay, so V2 is directly proportional, so it is equal to N2 by N1. Okay, so transformation ratio is nothing but the ratio of number of turns, secondary number of turns to the primary number of turns. Okay, and voltage and EMF is equal. You can write a small e2 or capital E2. Okay, this is induced EMF. So why? Because voltage more or less is equal to induced EMF. Okay, that's why V2 means E2, V1 means E1. Okay, and one more thing here. Okay, here we have to write down here I1 by I2. See, the difference is here V2 N2 E2, but here we got I1, not I2 by I1, I1. Why? In transformer, why I have to get, I have not written I2 by I1, V2 by V1, E2 by E1, N2 by N1, but here I1 by I2, not I2 by I1. Why? Input voltage not equal to output voltage in transformer. Input current is not equal to output current. Number of turns in primary turns is not equal to number of turns in secondary. Okay, right? Flux is common, frequency is common, 4.44 is common. Here also in transformer, power is common. Power, input power is equal to output power. Power will not change. Power is same. That is, input power is equal to output power. So by assuming that P1 is nothing but V1 I1, power is nothing but the product of voltage into current. Yes, P2 is nothing but V2 I2, V1 I1 V2 I2. Okay, V1 I1 V2 I2. Okay, right. Now if you write here V2 by V1, what will get here? I1 by I2. Yes, that's why I have written here V2 by V1. I have to write down I1 by I2. Yes, because of this only I have written. Because of this reason I have written V2 by V1 I have written. So here I have to write I1 by I2. So transformation ratio can be defined as it is the ratio of secondary voltage to primary voltage, or it is the ratio of secondary turns, number of turns to primary number of turns, or it may be ratio of primary current to the secondary current, or it is the ratio of secondary induced EMF to the primary induced EMF. Okay, this is the one more formula which is required to solve the problem. Okay, we will do one problem. on the EMF equation? Right. So, Amma listen, I have shared notes na. In the notes, derivation of EMF equation is different. What I have taught now, that is different than the notes given. So kindly follow the EMF equation. Okay, my note, whatever I explained, that one. Okay, don't follow the notes. It is very hard here. Derivation of EMF equation. Okay. అర్థమైందా అమ్మా? నేను నోట్స్లు ఇచ్చాను కదా, ఈఎంఎఫ్ ఈక్వేషన్ ఇచ్చిన నోట్స్కి ఇప్పుడు చెప్పిన దానికి డిఫరెంట్ ఉంది. అంటే 2 వేలో మనం ఈఎంఎఫ్ ఈక్వేషన్ రాబట్టవచ్చు. ఇప్పుడు నేను చెప్పింది రాసుకోండి. నోట్స్ ప్లీజ్ ఒమిట్ నోట్స్. ఈఎంఎఫ్ ఈక్వేషన్ అది చాలా హార్డ్, అది కష్టం. పై ఎం సైన్ ఒమేగా టీ అవన్నీ ఉంటాయి, కష్టం అది. ఇగో ఇక్కడ ఇదంతా రాసినాడు. ఇగో పై ఎం సైన్ ఒమేగా టీ కాసు ఇవన్నీ ఎందుకు మనకు? సైన్ కాస్ అంటే భయం కదా. నేను చెప్పిన దాంట్లో సైన్ కాస్ లేదు కదా, వదిలిపెట్టేసేయాలి. ఫైనల్గా మనకు అదే వస్తుంది ఆన్సర్, వేరే ఏం రాదు. ఓకే రైట్. Write down a 44 kVA a 44 ఏమన్నా a 44 kVA 1000 by 415 volts comma 50 hertz single phase transformer has 88 turns on the primary. Find number of turns in the secondary, full load primary and secondary currents, and the maximum flux in the question. Substitute the values in the formula. What is the EMF equation? N1 or V2 by 4.44 F N2. You can use any one formula. V1 by 4.44 F N1 or V2 by 4.44 F N2. You can use any one formula. What is that value? 0.0518 Webers WB. Okay. Write down the second problem. Okay, so with this, except induction motor, machines, all topics are over. Okay, induction motor I have to tell. Okay. చేశారమ్మా చేశారా? Can I ask the questions now? Can I ask the questions? Only one induction motor is left in the machines. Only working and principle is same with respect to transformer. Induction motor is principle is same with respect to transformer. What is the transformer principle? What is the transformer principle? Faraday's laws of mutual induction. Same principle holds good for induction motor, but constructionally different. Okay, constructionally different. Induction motor is nothing but rotating transformer. A transformer, if it rotates, okay, how we will get secondary induced EMF in the rotor of the induction motor? That is differs. Okay. Can I ask the questions now? One more question. So not the questions, no need to worry. So I am having one doubt here. Transformer is there, na? So instead of applying AC, I am applying DC. What happens? Instead of applying AC to the single phase transformer, I am applying a DC supply to the transformer. What happens? Nothing will happen. Can I apply DC to the transformer? Yes or no? ఎడమ చేత్తో అన్నం తింటామా? దానికి ఎస్ అంటే ఓకే. ఓకే, ఇఫ్ యూ అప్లై DC to the transformer, what happens? What happens? ఇది ఇంపార్టెంట్, ఇది 2 మార్క్స్కి చాలాసార్లు అడిగినాడు, అడుగుతాడు. సో కెన్ ఐ అప్లై DC to the transformer? No, we cannot. Justify your answer. Justify your answer. What happens actually? Why? What happens? I will tell you, write down that one. Okay. Okay, so here instead of applying AC, I am applying DC. DC means battery, plus minus. Yes, so I am applying a voltage of DC voltage, which is okay, DC voltage. How it could be? Constant DC voltage applying. Okay, so because of the circuit is closed, yes, a current of I will flow. So how this I DC only. So if you are able to apply DC, okay, you can apply. What happens actually? We cannot apply actually. If you apply, what happens? Okay, because of the closed circuit, a current of I will flow. So this is DC voltage, DC current. Instead of applying AC, you are just given DC. Battery you connected. Primary terminals you connected battery. Okay, because of the closed circuit, what happens? Current will flow. Okay, closed circuit means current will flow, but it is a DC current. Okay, so because of woundness, what happened? Because of woundness, current is flowing, wounding also there. So because of woundness, flux will be established. Flux will be established. This flux is constant 1. Yes, applied voltage is DC, current is DC, flux also DC. But in order to induce an EMF, what you require? d pi by dt. The flux has to change with respect to time. If the flux is changing with respect to time, constant. Okay, so because of the constant flux, okay, no induced EMF. No induced EMF, no E1, E1 is not available. No E2 is available. Okay, E1 is not available, primary induced available 0. Okay, so because of there is no induced EMF in the primary as well as secondary. E1 is 0, E2 is 0. Actually, this induced EMF will controls the applied voltage. Okay. Actually, this induced EMF E1 will controls the V1. If E1 is not there, who will control V1? Who will control E1? So there is no controlling. Is absent. If there is no controlling means what happens actually? This primary current will infinity. This primary current will, because of there is no control. Actually primary induced EMF what it will do? It will controls V1. So there is no control in the, because of there is no control, okay, I1 is goes to the infinity. What happens? If current is infinity, what happen? Primary winding will burn. What happened to secondary? No, secondary nothing will happen to secondary winding. Secondary winding nothing will happen. There is no E0, there is no I, there is no V2. Okay, E2 is 0, V2 is 0, I2 is 0. Nothing will happen to secondary winding. Okay, only primary winding will burn. This is the justification answer. Okay. So because of there is no controlling of the E1. Why? Because E1 is absent. Why E1 is absent? There is no induced EMF. Why? What is the principle? d pi by dt is equal to E. EMF is induced in the DC generator or AC generator if flux varies with respect to time. d pi by dt only, then E will be established. If there is no d pi by dt, only pi is there, there is no E. Only pi. Pi is not equal to E. You cannot say like this. Okay? You cannot say. d pi by dt only, you will get a E. So there is no d pi by dt. What do you mean by d pi by dt? Pi is changing with respect to time. So positive value, negative value, zero value, increasing value, decreasing value. That way, okay, flux has to be changed. So there is no change of flux. Flux is constant. Flux is constant means there is no induced EMF. There is no induced EMF means E1 is 0. Actually E1 will controls V1. So because of the controlling is absent, so primary current is increases rapidly and reaches to the infinity. If current is reaches to the infinity, what happens? The winding will burnt out. Infinity current means heating effect. More it will generate, more and primary winding will melts. Melting is nothing but burning. Melting of copper wire is nothing but burning. Okay, primary winding will burn. Okay, this is also very short answer question, 2 marks question. Okay, right. So after this, it is also very easy. Induction motor construction. See here, induction motor is very easy. Only two parts. One is stator, other one is rotor. Stator having the conductors, rotor is having conductors. There is no field here. There is no field. There is no field in the stator, and there is no field in the rotor. Means north pole, south pole. There is no north pole, south pole here. Okay, only slots. Rotor is having rotor slots. Stator is having stator slots. Okay, so this is about construction of the induction motor. You draw this, you will get practice. And you compare these three diagrams. You compare these three diagrams. DC generator, alternator and induction motor. Okay. Here there is no slip rings. Only slots and conductors. Slots and conductor. Okay, I will tell. This is a rotating transformer. Yes, transformer is having two windings. So induction motor also having two windings. One is in stator, one is in rotor. But it is a three-phase. It is a three-phase. Okay, three-phase winding. So here there is no color representation. It is a three-phase winding. Stator consisting of three-phase winding. Stator consisting of stator slots, which consisting of conductors. Rotor consisting of rotor slots and winding. So rotor winding also three-phase. Stator three-phase, rotor three-phase. There is no brushes. There is no slip rings. There is no commutator. Okay, only slots. So when compared to DC generator and alternator, construction of induction motor is very easy. If you know this working and construction, this machines part is over in this unit. Then we will move to the measurements. Okay. Up to what time? All are hostelers or day scholars? Up to 5 o'clock. 4:30 or 5? 4:30. Okay. Can I conduct exam? No. Fill in the blanks. Huh? Fill in the blanks. Objective type. From morning to now, whatever I explained, I will give 10 questions. You write down that answers. Huh? Okay? You will get practice now. No. No means you will fail. శపించాలనా నేను? శపిస్తా మరి. మరి సార్ శపిస్తే కష్టం. తెలుసా శపించడం అంటే? తెలుసా? కొత్తగా వింటుండ్రా వర్డ్? కొత్తగా వింటుండ్రా? all are belongs to America, I think, not India. Draw this diagram, you will get practice. Please be silent. Please. winding is called primary winding. So in the induction motor, stator winding is called primary winding, which is connected to the supply. What is the definition of the primary winding of the transformer? The winding which is connected to the supply. The winding which is connected to the supply is known as primary winding. Okay. The winding which is connected to the load is called secondary winding. So here the winding which is available in the rotor is called secondary winding. So I am saying rotating transformer. Why I am saying rotating transformer? Rotor of the induction motor will rotate. That's why rotating transformer. Rotating transformer. Okay. Right. So primary winding and secondary winding. So primary winding is nothing but stator. Stator consisting of stator slots. In the stator slots, three-phase winding is available. Okay, three-phase winding is available. At the same way, rotor is having rotor slots. In rotor slots, three-phase winding is available. But what is the difference between transformer and induction motor? So, induction motor, secondary winding is connected to the so it is primary winding. So primary winding, secondary winding. So common is core. Okay, so here I am using now primary winding in stator. Three phase 1, 2, 3 R, Y, B. Stator is having slots. Okay, in this we are having stator conductors. So rotor is also having rotor slots. Okay, here also rotor conductors. So this is also three phase. So three phase induction motor. So in primary and secondary we are having three phase induction motor. What is the principle here? Principle of Faraday's laws of mutual induction. Okay. Now, but what is the difference here? Secondary winding. In the induction motor, secondary winding is short circuited. Secondary winding of the induction motor is short circuited. Here transformer secondary winding is connected to load. Load means any electrical appliances, any electrical device. So here input is AC, output is AC. Here also primary winding is AC, rotor also having AC. But here whenever we are applying AC supply, this induction motor starts rotating. Okay, how it starts rotating? On what basis it is rotating? Simple. Okay, what happens? See, working of the induction motor. Working of the induction motor. Okay, time up. Time up kaadu inkundi. So here, whenever three-phase supply, that is AC, connected to the primary winding. Of induction motor. Okay, whenever this primary winding is connected to the primary winding, okay, connected to the supply, three-phase supply, I am switching on. I am switching on. It means simple fan. Okay, so here primary winding is available, primary conductors are available. So this because of the primary, that means stator having the winding. Okay, so this stator is capable of induce an EMF. Induce an EMF. In transformer also same. Transformer lo kuda EMF induce aithe kada, primary induced EMF. Here also primary induced EMF will induce. Okay. So at the same way flux will establish. In the stator. Okay. So flux is established here. Flux will establish like this. Flux is established in the stator conductors. In the stator conductors. So it is a three-phase winding. It is a three-phase winding which is 120 degrees apart. So this the flux which is established in the three-phase induction motor is rotating magnetic. We can say it is a rotating magnetic field. Rotating magnetic field. The flux which is established in the induction motor because of the primary winding of the induction motor, the flux will be established. This flux is will rotate. Rotate means not circle. It will rotate like this. Flux only rotate like this. Flux. Okay. So this rotating magnetic field. Okay. This rotating magnetic field is interacts or cuts the rotor conductors. Rotating magnetic field is available here. Rotating magnetic field available. So rotor is having also, it is in circular in nature. Circular. So rotor is having rotor conductors. It is a short circuited. Okay. So this rotating magnetic field will cuts the rotor conductors. Okay. Will cut the rotor conductors. Okay. Interacts or cuts the rotor conductors. So an EMF. Again E2 in transformer E2 will be available. Here also an EMF induced in the rotor. Okay. So this whatever the EMF induced in the rotor, here also a magnetic field will be established. Why? Because it is a three phase. Rotor conductors also three phase. Stator conductors also three phase. So rotating magnetic field established. Rotating magnetic field established. Okay. So in stator rotating magnetic field established. In the rotor also rotating magnetic field established. E1, E2, pi1, pi2, rotating magnetic field established, and rotor also rotating magnetic field established. So these two fluxes interacts each other, which will these two flux. Okay, one is because of the rotating magnetic field because of stator. Okay, rotating magnetic field because of rotor. So one is rotating like this because of stator. Because of the rotor, other magnetic field also rotating. So both are, these fluxes are revolving each other, interacts each other, revolving each other, thereby the rotor starts rotating. Okay, these two fluxes will try to move the rotor in a clockwise direction or anti-clockwise direction. Okay, so because of the two fluxes, because of the stator flux and because of the rotor flux, the rotor starts moving. Okay, so because of the both fluxes, rotor starts rotate. ఓకే, మరి మీకు ఏం అర్థమైందో నాకైతే తెలియదు కానీ ఓకే. సింపుల్, V1 ఈజ్ దేర్, E1 ఈజ్ దేర్. ట్రాన్స్ఫార్మర్ అమ్మా, ట్రాన్స్ఫార్మర్ వస్తే ఇది వస్తుంది, V1 ఉంది, E1 వస్తుంది కదా, ట్రాన్స్ఫార్మర్లో E1 వస్తుందా, పై వస్తుందా, అక్కడ పై వస్తుంది, ఇక్కడ పై వస్తుంది. బట్ బికాజ్ ఆఫ్ ఇట్ ఇస్ త్రీ ఫేజ్ వైండింగ్, అది త్రీ ఫేజ్ వైండింగ్ కాదు ట్రాన్స్ఫార్మర్, ఓన్లీ రెండే ఉన్నాయి కదా టెర్మినల్స్, ఇక్కడ 3 టెర్మినల్స్ ఉన్నాయి RYB. సో బికాజ్ ఆఫ్ త్రీ ఫేజ్ కనెక్షన్, త్రీ ఫేజ్ వైండింగ్, ద ఫ్లక్స్ విచ్ ఈజ్ ఎస్టాబ్లిష్డ్ ఇన్ ద స్టేషనరీ ఈజ్ రొటేటింగ్ మ్యాగ్నెటిక్ ఫీల్డ్ వస్తుంది. ఆ ఫ్లక్స్ ఏంటంటే ఇట్లా తిరుగుతుంది, ఇట్లా వీ కెనాట్ సీ దట్ వన్. ఓకే, ఇలా తిరుగుతుంది. సో దిస్ ఫ్లక్స్ ఈజ్ ఇంటరాక్ట్ విత్ రోటర్ కండక్టర్, రోటర్లో కూడా కండక్టర్స్ ఉన్నాయి కదా. సో రోటర్లో కండక్టర్స్ ఉన్నాయి కాబట్టి ఆ ఫ్లక్స్ ఈ రోటర్ కండక్టర్స్కి టచ్ అవుతుంది. టచ్ అవుతే ఏమవుతుంది, దీని దిస్ రోటర్ కండక్టర్ ఈఎంఎఫ్ విల్ ఇండ్యూస్. E2 ట్రాన్స్ఫార్మర్లో కూడా E2 వచ్చింది కదా, బికాజ్ ఆఫ్ పై ఓన్లీ. ఓకే, మ్యూచువల్ ఇండక్షన్ ఇక్కడ కూడా E2. సో E2 వచ్చింది కదా, E2 వచ్చిన తర్వాత ఏమైంది, దిస్ రోటర్ ఈజ్ హ్యావింగ్ షార్ట్ సర్క్యూటెడ్ త్రీ ఫేజ్ వైండింగ్. ఓకే, సో దిస్ రోటర్, ఇన్ రోటర్ ఆల్సో ఏ రొటేటింగ్ మ్యాగ్నెటిక్ ఫీల్డ్ ఎస్టాబ్లిష్డ్. సో రోటర్లో కూడా రొటేటింగ్ మ్యాగ్నెటిక్ ఫీల్డ్ వస్తుంది, అది కూడా ఏంటి, అది కూడా క్లాక్ వైజ్ తిరుగుతుంది. ఓకే, తిరుగుతుంది. ఓకే, రొటేటింగ్ మ్యాగ్నెటిక్ ఫీల్డ్ తిరుగుతుంది. సో ఈ రొటేటింగ్ మ్యాగ్నెటిక్ ఫీల్డ్, ఈ రొటేటింగ్ ఫీల్డ్ రెండు ఇలా ఉంటుంది కాబట్టి రెండు ఏం చేస్తాయి, అప్పుడు ఆ రోటర్ని మూవ్ చేస్తారు. సో దెన్ ద రోటర్ ఆఫ్ ది ఇండక్షన్ మోటార్ విల్ స్టార్ట్ రొటేటింగ్. అది దిస్ ఈజ్ కాల్డ్ డబుల్ రివాల్వింగ్ థియరీ అంటారు, డబుల్ రివాల్వింగ్ థియరీ అంటారు ఇది. ఓకే, దిస్ ఈజ్ ద వర్కింగ్, కన్స్ట్రక్షన్ అండ్ వర్కింగ్. సో ఇందులో మీకు కన్స్ట్రక్షన్ ఈజీ కాబట్టి ఇందులో ఇండక్షన్ మోటార్లో ఇది అడుగుతాడు. ఎక్స్ప్లెయిన్ ది వర్కింగ్ ఆఫ్ ది ఇండక్షన్ మోటార్, ఎక్స్ప్లెయిన్ ది కన్స్ట్రక్షన్ ఆఫ్ DC మెషిన్. ఓకే, డిరైవ్ ది EMF ఈక్వేషన్ ఆఫ్ ది ట్రాన్స్ఫార్మర్, ప్రాబ్లమ్ ఆన్ ది ట్రాన్స్ఫార్మర్. ఇవన్నీ ఇంపార్టెంట్స్. ట్రాన్స్ఫార్మర్లో ఏమి ఇంపార్టెంట్, కన్స్ట్రక్షన్ ఈజీ కదా, ట్రాన్స్ఫార్మర్లో EMF ఈక్వేషన్, ప్రాబ్లం. DC జనరేటర్, DC మోటార్లో కన్స్ట్రక్షన్, ఎందుకంటే అవి హార్డ్ కదా కన్స్ట్రక్షన్. ఓకే, ఇందులో ఇది ఆల్టర్నేటర్ ఆల్సో కన్స్ట్రక్షన్. ఓకేనా. సో దిస్ ఈజ్ అబౌట్ మిషన్స్. ఓకే, DC generator, DC motor, AC generator, AC motor, that is induction motor and alternator and transformer. EMF equation of the DC generator, EMF equation of the transformer, problems. ఓకేనా. ఇది ఒకసారి మీరు నోట్స్లో ఉంది, 10 సార్లు చదవండి, అర్థమవుతుంది. ఓకేనా. దిస్ ఈజ్ అబౌట్ టోటల్ మెషిన్స్ టాపిక్స్. ఓకే, నెక్స్ట్ విల్ స్టడీ అబౌట్ మెజర్మెంట్స్ చదువుదాం. ఓకే, సో ఇన్ ద మెజర్మెంట్స్ వాట్ ఆర్ ద టాపిక్స్ యు ఆర్ హ్యావింగ్, ఓన్లీ 3 టాపిక్స్. నేను ఇంతకుముందు కూడా చెప్పిన, మరి మీకు ఈవినింగ్ వల్ల చెప్పలేకపోయినా ఏంటో తెలియదు, ఐఎమ్ అనేబుల్ టు రిమెంబర్. ఓకే, మూవింగ్ కాయిల్ ఇన్స్ట్రుమెంట్, దట్ ఈస్ PMMC, అండ్ మూవింగ్ ఐరన్ ఇన్స్ట్రుమెంట్స్ అండ్ వీట్స్టోన్ బ్రిడ్జ్. ఈ 3 టాపిక్స్ అంతే. పర్మనెంట్ మ్యాగ్నెట్ మూవింగ్ కాయిల్ ఇన్స్ట్రుమెంట్, పర్మనెంట్ మ్యాగ్నెట్ మూవింగ్ ఐరన్ ఇన్స్ట్రుమెంట్ అండ్ వీట్స్టోన్ బ్రిడ్జ్. ఈ 3 టాపిక్స్ ఉన్నాయి ఈ యూనిట్లో. ఓకే, సో ఈ మెజర్మెంట్స్ చెప్పాలి అంటే యూ రిక్వైర్ టు నో అబౌట్ 3 టాక్స్. చెప్పాలా ఇప్పుడు, టైం ఉందా? 3 టాక్స్ వీ రిక్వైర్. ఓకే, వెయిట్ చెప్పండి, వెయిట్. వన్ ఈజ్ కాల్డ్ డిఫ్లెక్టింగ్ టార్క్. Second one is called controlling torque. Third one is called damping torque. if you are able to understand about these three talks, if you are able to understand these three talks, then we have to design any electrical, any instrument, measuring instrument, any measuring instrument. We will implement these three talks in that instruments. వోల్ట్మీటర్ ఉందనుకోండి, ఆ వోల్ట్మీటర్లో ఈ త్రీ టాక్స్ ఉంటాయి. అమ్మీటర్ ఉందనుకో, ఆ అమ్మీటర్లో ఈ త్రీ టాక్స్ ఉంటాయి. ఓకే, మన ఇంటి దగ్గర మీటర్ ఉంటుంది కదా, ఎనర్జీ మీటర్ అంటారు, ఆ మీటర్లో కూడా ఈ త్రీ టాక్స్ ఉంటాయి. అసలు ఈ త్రీ టాక్స్ ఏంటి, వాట్ ఈస్ ద మెయిన్ ఇంపార్టెన్స్ ఆఫ్ దిస్ త్రీ టాక్స్, వై ఇట్ ఈస్ రిక్వైర్డ్, వాట్ ఈస్ మీన్ బై డిఫ్లెక్టింగ్ టార్క్, వాట్ ఈస్ మీన్ బై డాంపింగ్ టార్క్, what is mean by controlling torque. If you are able to understand the definition and how we are implementing this torques, ఈ టార్క్ రావాలంటే ఏం చేయాలి, ఈ టార్క్ ఇప్పుడు ఎగ్జామ్ మార్క్స్ రావాలంటే ఎగ్జామ్ రాయాలి, మరి ఈ టార్క్ రావాలంటే మనకు ఏం ఇన్స్ట్రుమెంట్ కావాలి, ఎలా డిజైన్ చేయాలి, డిఫ్లెక్టింగ్ టార్క్ కావాలి, ఏం డిజైన్ చేయాలి, మిషన్లో అది ఆ ఇన్స్ట్రుమెంట్లో ఏం ఉండాలి, డిఫ్లెక్టింగ్ టార్క్ అంటే అక్కడ ఇన్స్ట్రుమెంట్లో ఏం ఉండాలి, డాంపింగ్ టార్క్ అంటే ఇన్స్ట్రుమెంట్లో ఏం ఉండాలి. ఈ మూడు టార్క్స్ ఉంటే ఒక ఇన్స్ట్రుమెంట్ రెడీ అవుతుంది. ఇన్స్ట్రుమెంట్ ఏది, మెజరింగ్ ఇన్స్ట్రుమెంట్, మెజర్ చేస్తాం కదా, ఏది అనలాగ్. అనలాగ్ ఇప్పుడు మన ఎనర్జీ మీటర్ ఉందా ఇంట్లో, ఆ ఇంట్లో ఉన్న ఎనర్జీ మీటర్లో ఈ త్రీ టార్క్స్ ఉంటాయి. ఏదైనా సరే డిస్ప్లే అనలాగ్, డిజిటల్ కాదు, 1 2 3లో వచ్చేది కాదు, అనలాగ్. ఇలా మనము కనెక్ట్ చేయగానే ఇలా తిరుగుతుంది కదా, మీకు అందరికి బైక్స్ ఉన్నాయి కదా, 1 2 3లో వచ్చేటి కావు. స్పీడ్ వెళ్తుంటే మనది అది ఉంటుందా, స్పీడోమీటర్, డిఫ్లెక్ట్ అవుతుంది కదా, దాన్ని ఇప్పుడు ఇట్లా ఉన్నదాన్ని ఇలా అవుతుందా, డిఫ్లెక్ట్ అవుతుంది కదా. సో ఇన్ ఆర్డర్ టు మూవ్ దట్ పాయింటర్ ఫ్రమ్ 0 to రిక్వైర్డ్ ప్లేస్, వీ రిక్వైర్ డిఫ్లెక్టింగ్ టార్క్. అది ఉంది కదా, 0 నుంచి ఇలా వెళ్తుంది కదా, 30 స్పీడ్తో వెళ్తున్నావు, 20 స్పీడ్తో వెళ్తున్నావా, ఓకే, ఆ పాయింటర్ని 0 నుంచి ఇక్కడ దాకా ఎవరు తీసుకెళ్తుండ్రు, డిఫ్లెక్టింగ్ టార్క్ తీసుకెళ్తుంది, డిఫ్లెక్టింగ్ టార్క్. మరి అక్కడే 60 దగ్గరనే ఎందుకు వస్తుంది, మరి 100 ఎందుకు పోవట్లే, పోవాలి యాక్చువల్గా, మొత్తం 360 degrees తిరగాలి అది యాక్చువల్గా, మరి తిరగట్లే, ఫ్యాను తిరుగుతుండదు కదా, మరి అది తిరగదు కదా, ఓన్లీ ఒక దగ్గరికి వచ్చి ఆగుతుంది కదా. 20 అంటే 20 దగ్గరికి వచ్చి ఆగుతుంది, 60 అంటే 60 దగ్గరికి వచ్చి ఆగుతుంది. స్పీడ్ ఎందుకు ఆగుతుంది, ఎందుకంటే ఆ టార్క్ని కంట్రోలింగ్ టార్క్ కంట్రోల్ చేస్తుంది, కంట్రోలింగ్ టార్క్ కంట్రోల్ చేస్తుంది. ఆల్వేస్ ఎట్ పాయింటర్, పాయింటర్ అంటే తెలుసు కదా, ఎట్ పాయింటర్ TD ఈజ్ ఈక్వల్ టు TC, ఇది గుర్తుపెట్టుకోవాలి మీరు. At pointer where it is showing, for example it is showing at 20, there deflecting torque is equal to controlling torque. Compulsory, any instrument deflecting torque is equal to controlling torque. తర్వాత మీరు ఇంకోటి కూడా, మీరు అఫ్ కోర్స్ బైక్ నడుపుతారు కాబట్టి చెప్తున్నా, ఇది ఒక దగ్గరకు వచ్చి ఇలా ఇలా ఊగుతారు కదమ్మా, ఇలా ఇలా అవుతుంది కదా, ఇలా ఇలా కాదా, ఇలా ఇలా అవుతుందా, దాన్ని ఏమంటాము, నవ్వొస్తుంది అంటే అఫ్ కోర్స్ చదువుకుంటున్నాం, నవ్వాలి వద్దనట్లేదు, కానీ దట్ ఈస్ కాల్డ్ డాంప్నెస్. మీరు బ్లేడ్ ఉందా మీ దగ్గర, బ్లేడ్ని ఒకసారి ఇట్లా అంటే ఏమవుతుంది, ఒకసారి ఇట్లా అంటే, ఒకసారి ఇట్లా అంటే, ఇలా పట్టుకొని ఇట్లా అంటే ఏమవుతుంది, ఇలా ఇలా అవుతుందా, దట్ ఈస్ కాల్డ్ డాంప్నెస్. దీన్ని ఏం చేయాలి మరి, వీ హ్యావ్ టు reduce damping torque. Okay, so damping torque will be available, will be generated in the instrument, but then we cannot avoid this. Okay, జ్వరం రావడాన్ని అవాయిడ్ చేయవచ్చా, జ్వరం రావడాన్ని అవాయిడ్ చేయవచ్చా, చేయరాదు, వచ్చిన తర్వాత తగ్గించుకుంటాం, అంతేనా, ఏమో మరి నాకైతే తెలియదు. ఇప్పటిదాకా మీకు ఎవరికి ఫీవర్ రాని వాళ్ళు ఉన్నారా, ఉండరు, ఎవరు ఉండరు, ఓకే, అర్థమైంది కదా. ఎట్ ది సేమ్ వే వీ కెనాట్ అవాయిడ్ దిస్ డాంపింగ్ టార్క్, వీ కెనాట్ అవాయిడ్ దిస్ డాంపింగ్ టార్క్ ఇన్ ద ఇన్స్ట్రుమెంట్, బట్ we will try to reduce this damping torque. We will try to reduce the damping torque. We cannot avoid to getting fever, but we will reduce the fever by taking appropriate tablets. Okay, so these three talks are required in any measuring instruments. So these are always available in any instrument. In speedometer also. In all analog meters, voltmeter, ammeter, speedometer, okay, energy meter, wherever the pointer is there, analog meters, these three talks are okay. What is the importance of these talks? Why it is required? I will explain in the next class. Okay? Not by madam will take class. Ten questions అన్నా కదా రాస్తారా మరి 10 questions ఇప్పుడు? 10 questions 10 minutes. Hmm. 10 questions, you write down the 10 questions. Okay? Write down only 10 questions. 10 minutes కూడా కాదు, 1 minute లో అయిపోద్ది. రాయండి, మీకే మంచిది కదా, 1 mark 10 marks వస్తాయి సెమిస్టర్ ఎగ్జామ్లో. మార్నింగ్ నుంచి ఇప్పటివరకు చెప్పిన దాంట్లోనే. అమ్మా సైలెన్స్. ఓన్లీ 5 ఉన్నాయా? ఈ 5 రాయండి ఫస్ట్ అయితే. రైట్ డౌన్ దిస్ వన్, 5 questions. Amma, don't copy. Don't copy. What you know, you write down. What you know, you write down. Madam will correct your paper and they'll allocate the marks. Okay? Respect your class madam will correct this one and madam or sir will allocate the marks. Okay? వాట్ యు న్యూ రైట్ డౌన్, డోంట్ కాపీ. కాపీ చేస్తే ఏమి రాదమ్మా. Remaining 5 questions I will write and I will go. మళ్ళీ ఎప్పుడు సరే అదే ఎన్ని గంటలకు అవు? ఓకే 5 questions రాసి వెళ్ళిపో అమ్మ. ఐ విల్ రైట్ రిమైనింగ్ 5 questions, దెన్ యూ రైట్. మీకు నెక్స్ట్ పేజ్ ప్రీవియస్ పేజ్. Okay, you write down these 6 questions. Okay, ఇప్పుడు ఈ 6లో మీకు 5 వచ్చిన 5 కరెక్ట్ వచ్చిన మార్నింగ్ నుంచి ఇప్పటివరకు నేను చెప్పిన దానికి అర్థం ఉంది. ఇక నీకు రాలేదు అంటే చాలా కష్టం, మీ ఇష్టం, ఇక దట్ ఈస్ అప్ టు యూ. ఓకే, రైట్, థ్యాంక్ యూ.